This video is about inverses. So we're going to be talking about inverses, which is pretty much exactly what it sounds like, and that is backwards stuff. Let's take a look at the part of the notes I've already completed. So we've got these points that I plotted, and they're the points that are here in red. And our domain, as you can tell, our x values go from 0 to 4. Our y values go from -3 to 5. When we say find the inverse, what we're doing is taking these points and basically flipping where the x and the y are. So I did that, and I came up with the blue with the open circles. Now notice how the domain flipped and the range flipped from what they were in the previous function. So they kind of traded places. That's kind of what's going on with inverse functions. Also note this line, this y equals x line for what we're doing, is the mirror basically over which we are flipping our points. So one way to test this is the horizontal line test. So let's scroll down and have a look at that. The inverse of a function is a function if and only if no horizontal line intersects the original graph more than once. So let's see if g of x is passing the vertical line test. So, okay, I'm going to move my vertex up to 0, 5 here. I can see that it's got a negative, so that means that my parabola is going to open upside down, and the squared indicates it's a parabola. Let me just plot those points real fast. 2 and 1, 1, 2, 3, 4, 4, 5, 6. So here's our parabola. It's a rough kind of sketch. And if I draw a horizontal line across this, and I'll just draw one here in blue, we can see that it crosses our graph 1 time, 2 times. So is g of x a function? Does it pass the vertical line test? Yes, it does. Is the inverse a function of x? The answer here is no, because our horizontal line touches our graph more than once. Let's try it with our next one, f of x. So we're going to start our y-intercept at -2 right here. Our slope is 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. I'll get my ruler and try to make it look relatively straight. Does this pass the vertical line test? If I drop a line, it only hits it once, so it passes. Take a horizontal line, and I can pass it anywhere along this graph, and it's only going to hit it in one place. So is f of x a function? Yes. Is its inverse a function? Also yes. All right, so looking at a graph on a coordinate plane, looking at one of these equations on the coordinate plane and its inverse is pretty straightforward. The interesting stuff gets to be when you're doing the work here. So we are literally going to do the exact same thing, and that's swap x and y. So let's actually see that in action. The first thing I'm going to do is rewrite my equation with a y instead of an f of x or g of x or whatever. So I'm going to rewrite this as y equals 2x plus 3. After that, step 2 is switch where x and y are. So x equals 2y plus. Now we're going to solve for y. I want to make this y equals again algebraically. So I'm going to start by getting the 2y by itself, subtracting the 3, to give us x minus 3 is equal to 2y. Now I want to get the y by itself, so I'm going to divide by that coefficient 2, and change colors to green here. Divide by 2. Now I get that x minus 3 divided by 2 equals y. And it's totally fine to leave it like that. If you want to do x divided by 2 minus 3 divided by 2 equals y, it's the same thing. But I'm going to leave it like this. What I'm going to do now is make it look nice and use the proper notation. So the proper notation is f with a little tiny -1 floating as a superscript. So f and the -1, that means inverse. of x is equal to x minus 3, the quantity divided by 2. And that's all there is to it. When you are working this kind of problem, you will get fractions, and that's okay. Don't be freaked out by them. Let's look at the next example, B. All right, so let's take a look at this problem. What we're going to do, just like before, is start off by changing the f of x to a y equal. So y equals negative 3/4 x minus 5. What I want to do here is now swap the x and the y. So x equals negative 3/4 y minus 5. I could start working here, but I don't like the fraction in there, so I'm going to go ahead and get rid of it. And I'm going to do that by multiplying all of the terms by the denominator of the fraction, which is 4. So 4 times x would be 4x. 4 times negative 3/4 would be negative 3. The numerator just kind of falls out. And then 4 times negative 5 is negative 20. Now I can solve it for like a normal equation. I'm going to start off by adding 20 to both sides to cancel that out. 20 to both sides. And we get 4x plus 20 equals negative 3y. At this point, I'll divide by that coefficient, that negative 3. Divide by negative 3. I want to take a second here and say that when you're dealing with algebra, you're technically not supposed to have a negative number in your denominator. So I'm going to take that negative out of my denominator and put it in my numerator on this part on the left here. And I'm going to distribute that. So this becomes negative 4x minus 20 divided by 3. So that negative just got applied to the top instead of the bottom. It means essentially the same thing. The other side, those negatives cancel out, and I get just a nice pretty y there. What I'm going to do now is transfer this over to the correct format, which would be f, little negative 1, x. Inverse of the function would be negative 4x minus 20 divided by. On to the last example, C. You can see this one's a little bit different. It's got the exponent, so this is a quadratic. This one's also got a domain constraint. So as we can see, x has to be greater than 0, so the positive numbers. If we were to graph that, that would be like the right-hand side of the u. That also means that when we solve this, we're only going to care about positive solutions. So let's go ahead and convert this over, just like we were doing before. Convert the h of x over to a y. Y equals x squared plus 5. Our step 2 is the same. We're going to trade where the x and the y are. X equals y squared plus 5. We're going to move the 5 over by subtraction. So we're going to take 5 away from both sides and get that x minus 5 is equal to y squared. At this point, if you're a little confused about what to do, that's totally okay. This is probably not something you covered in Algebra 1. The opposite of the square is going to be the square root. So to undo that square on the y squared, I'm going to take the square root of both sides of my equation. Just like this. Now normally, yes, there would be a positive root and a negative root, but because of our domain constraint, we're only really concerned with the positive solutions. So I'm going to ignore my negative solutions as extraneous for this exercise. So that means that the square root of x minus 5 is equal to y. So I'm going to take that and I'm going to make it pretty with the correct format. And that would be the little negative 1. So f, little negative 1, the inverse of f of x, is the square root of x minus 5.